Bell curves, or normal density functions, are frequently used, and they crop up quite a bit as the densities of random variables that we observe in everyday life. And there are tables, and you can also calculate probabilities for these distributions precisely on your calculator and with software. In this course, we're not going to look at how to use those tables or how to use calculators to calculate probabilities. Instead, we're going to satisfy ourselves with this rule of thumb called the empirical rule. If a random variable has a bell-shaped distribution, or a distribution that's approximately bell-shaped, we have the following interpretation of the standard deviation. The probability that we observe an outcome within one standard deviation of the mean is approximately 0.68. So the probability that our observation will fall in the interval from mu minus sigma to mu plus sigma is 0.68. On the other hand, 95% of the outcomes are going to fall within two standard deviations of the mean. So the probability that my observation will be in the interval from the mean minus 2 standard deviations to the mean plus 2 standard deviations is approximately 0.95. And 99.7% of the outcomes I observe will fall within 3 standard deviations of the mean. So the probability of observing something in the interval from mu minus 3 sigma to mu plus 3 sigma is 0.997. Here's a graphical representation of the empirical rule. You see the bell-shaped density function in red, and we're saying that the area under that curve from mu minus sigma to mu plus sigma, one standard deviation below the mean to one standard deviation above, is approximately 0.68, or 68% of our observations will fall within that interval. 95% of our observations will fall within 2 standard deviations of the mean, in that interval from mu minus 2 sigma to mu plus 2 sigma, and almost all, 99.7% roughly of our observations, will fall within 3 standard deviations of the mean. This means that if this is the density curve for our random variable x, that observations that are more than 3 standard deviations away from the mean, either above or below, are truly exceptional.